Hi, in this tutorial we will learn about a new chapter which is limits. So you have not learned limits in school, so this is quite new for you. So make sure you listen to the videos carefully and try to understand my explanations. Do all of the exercises and try to follow my steps. So in this tutorial we will learn about the test for existence of a limit. So what is the test for existence of a limit? It is whenever we want to check whether a limit of a function exists or not. So when does a limit exist? So it's whenever, when you look at the formula here, why is there a negative right on top of a, superscript of a? Well, that's because when it's written a to the power of negative, it means this is the limit from the left side of function fx. And what about the one equal to it? There's a superscript of a positive. This means it's the limit from the right side of fx. So when does the limit equals? It's whenever the limit from both left and right side is equal to a number. So let's say it's equal to 5. So the limit exists and is equal to 5. But if let's say from left hand side and right hand side the limits are not equal, then the limit does not exist. Okay, let's look at example 1. What does this mean? This means limit x cubed where x goes to 2 if it exists. Alright, so let's say this is quite hard to picturize if I want to explain this definition. So I draw a graph. You don't have to draw this in exams, but I just want to explain what does this definition means. Okay, so what do we have to do for first thing, example, determine if the limit of x cubed if it exists. This means our function is x cubed. That's why I draw the function x cubed. Okay, and then we want to determine whether the limit exists at x approaching to 2. Can you see that? X approaching to 2. So this means x value 2 is somewhere in the graph here. X approach 2 from the left hand side. Negative means from the left hand side is the value of, well, if it's hard for you to see from the graph here, you can just simply take a ruler and just move your ruler so that it's going to approach the value x equal to 2. Okay, so this is value x equal to 2, right? So this is not y. What will be the value of our limit? That will be the y, right? So let's take a look. From the left hand side of 2, when I move my ruler, the value of y will reach this value, okay, this point. And what is the value of limit at this point? Is when x is equal to 2, the value of y here is equal to, that's what we have to find. And to find that y, this is just substituting the value of 2 into the function. So I can just substitute 2 into this function. So this is 2 cubed equal to 8. Then you can write your answer like this. Limit as x approaching to 2 from the left hand side of x cubed is equal to, from the left hand side just now, from the left side of x equal to 2, the value of y here is approaching to 8. Okay, so the answer is 8 here from the left hand side. And let's take a look at the answer when we want to look at the function from the right hand side of that function. Okay, so just take a look at the right hand side of this function. Right hand side of x equal to 2. So from the right hand side of x equal to 2, just move your ruler from the right side of this function. So the function moves approaching to 2 from the right hand side And the value of y here stops at 2 here is 8, also 8. Okay, then we can conclude that since the limit from both on the left and also on the right side is equal to a number, then the limit exists. We can write a conclusion since limit from the left hand side is equal to the limit from the right hand side, then limit of x approaching to 2, x cubed, is equal to 8. That's how you should write answer. But what if the answer is not equal? Let's say these two answers are not equal, then the limit does not exist. Let's look at example 2. Use the graph below to determine the indicated limits. Okay, look at first question. Example 2a. Limit of fx when x is approaching to -4, positive. This positive here means that it's from the right side of -4. Right side of x equal to -4. So let's take a look. This is -4, x -4, okay? But this positive sign means that from the right side of x equal to -4. So we are looking at x equal to -4 value, but from the right side of -4. Don't look at the left side of -4. So what is the value of y from the right side of -4? You can just move your ruler following this graph, because fx here means all of the lines on this graph. So move your ruler to the right side of x equal to -4. And as you can see, this graph is the value of y for this graph is approaching to, where is it going to? It's going to infinity. Okay, so the answer here would be equal to positive infinity. Okay, because the value of y at -4 from the right side is approaching to positive infinity. Remember, limits is just a number which approaches to that value of y. It's not exactly a number there. Let's look at -2. B question. X approaching to -2. There's no positive or negative on top of this number -2. That means we have to look at -2 from the left side and also from the right side of -2. Because if they are not equal, then the limit does not exist. Remember the definition. Okay? Right. So let's look at the graph of -2 from the left and right. So from the left of -2 and from the right of -2. So let's focus on one side first. From the left side of -2, move your ruler and follow the graph. Don't bother about the axis. Axes are just there. It's like it doesn't even exist. Okay, so the graph is here. So just follow the graph and make sure the graph is approaching to x equal to -2, and this is x equal to -2. As you can see, the graph, the value of y for this graph when it approaches to -2 is stops here. So the value of y here is equal to, what is the value of y here? On x-axis, the value of y is equal to 0 here. Okay, as you can see, at -2, there's an empty circle here. That means the graph does not even exist at -2. The function doesn't even exist at -2. But now for limits, we don't care about exactly at -2. We just care about what's on the left and right side of -2. Okay, so from the left side of -2, it is approaching to the value of y equal to 0. Okay, so that's why we should write our answer here. write first, limit x approaching to negative 2 from the left hand side, fx is equal to 0. And then we take a look at the right hand side of negative 2. So from the right side of negative 2, focus on the graph from right side of negative 2. So this is the graph from right side of negative 2. So you're going to go and approaches this x equal to negative 2 line. Okay, so this graph is here from the right side of negative 2 and it stops here. So this is the value of your limit from the right side of negative 2. And what is the y here? The y value here is 4. So you should write your answer here as limit from the right side, positive as the superscript means that it's from the right side of negative 2. Okay, so stop at negative 2, x equal to negative 2, and look at your value of y. The value of y here is 4. So what is your conclusion? Does the limit of x approaching to negative 2 from the left and right side equal? As you can see, we have written that one side is 0, the other side is 4. So it's not equal. So if it's not equal, we have to write our conclusion as since limits from the left hand side of negative 2 is not equal to the limit from the right side of negative 2. So the conclusion is limit of fx when x approaches to negative 2 doesn't exist. Look at example C. At example C, the question wants you to check whether the limit exists from the left and right side of 1. So this is value of x equal to 1. It's here. Okay, so we want to check whether the limit from the left hand side and from the right hand side of 1 is equal. If it's equal, then the limit exists. If it does not equal, then the limit does not exist. Okay, let's take a look. From the left hand side of x equal to 1, this is our graph. Okay, so just follow the graph until you reach x equal to 1. Then you stop. Right, at x equal to 1 here, there's an empty circle. Okay, but remember, we don't care what happens exactly at 1. We just care what happens approaching to 1. So this means at 0.99999, the graph stops at this value, which is negative 1. So the value of limit is negative 1. So you should write your answer here as, write your left hand side first. So write that superscript negative on top of 1, fx, which refers to this whole function with the lines. From the left hand side of 1 means the value of y is negative 1. So write negative 1 there. Now we have to check what is the limit from the right side of x equal to 1. So from the right side of x equal to 1, okay, so look at the right side of 1. What is the graph? So this is the graph which approaches to the right of 1. Okay, so for this graph, as you can see, the value of y here is negative 2. So you write negative 2 here. What's your conclusion? Does the limit exist? From the left hand side, the limit is negative 1. And from the right hand side, the limit is negative 2. So the limit does not equal. So this means that the limit does not exist. Hence, the limit of fx when x approaches to 1 doesn't exist. Now, let's look at example D. D here states that x approaching to 4. But there's no 4 here. on our x-axis. There's -4, there's -2, there's 1 value, but there's no 4. But we know that 4 is positive and it's to the right of 1. So it's somewhere here maybe. So just label your number 4 there. Remember, we have to follow the steps. We have to check from the left-hand side and also from the right-hand side of 4. If the answer is equal, then the limit exists and that's the value. Okay, so from the left-hand side of x equal to 4, this is the value of x equal to 4. From the left-hand side of x equal to 4, the graph is approaching to this value at 4. And what is the value of y here? We can see the value of y here is actually -2. So we can write the answer as, okay, remember we write the superscript negative on top of 4, which refers to the left-hand side of x equal to 4. From the left-hand side of x equal to 4, the value of y here is -2. That's why we write -2 here. Right, let's check what is the limit from the right-hand side of 4. Write that superscript positive on top of 4. So from the right-hand side of 4, just move our ruler approaching to x equal to 4 from the right side. Okay, so that's the graph here. So follow that graph and stop at x equal to 4. So we stop here. What is the value of y right at this point? The value of y at that point is -2. So what's our conclusion? Does the limit exist? As you can see, the limit from both of left and right side of x equal to 4 approaching to the same value, which is -2. So we can say that since limit 4 from the left is equal to the limit from the right side and is equal to -2, then we can state that the limit is -2. Let's look at E. E here states that the function, we want to check whether the function exists as x approaches to infinity. And where is infinity? This is positive infinity. So that means it's to the right of this axis. Okay. But as you can see, there's no graph here. But this is a line of y equal to -2. It starts at 1 here. And then, as you can see, it doesn't even stop. There's no empty circle here. There's no dense circle here. So that means this graph doesn't even stop. But it's just not being drawn as long enough. So we have to draw this graph longer, extend the graph. Okay. So as you can see, at positive infinity, this graph will still continue. So that means from the left hand side of positive infinity and also from the right hand side of positive infinity, the value is still -2. So we can write here simply the limit as x approaches to positive infinity is equal to -2. Okay, thank you.